Alright, welcome back. Big props for making it this far. In this video, we are going to become rock stars in JVM thread communication by enhancing the producer-consumer problem even further to allow multiple consumers and multiple producers on a limited capacity buffer. Let's get to it. Alright, we're back in the IDE, and we are going to practice the JVM thread communication model to become really badass programmers on level 3 of ProdCons. So ProdCons level 3 basically says we have a limited capacity buffer, but we have multiple producers and multiple consumers acting on the same buffer. So we have producer 1, producer 2, which wants to act on the same buffer, and so does another consumer. And we can have as many producers and as many consumers as we want, even in disproportionate amounts. So we want to support that. I will launch this first as a challenge to you. So if you want to pause the video, I really encourage you to do it. You can enhance the code that we've written so far, that we wrote for the ProdCons large buffer. The code that we're going to write is very similar. It just needs some logic adjustments. So I encourage you to enhance the code that we wrote to allow for multi-producers and multi-consumers. If you do this on your own, you are a rock star. After you're done, follow along with me and see how your solution compares to what I'm going to write here. Alright, so I'm curious to see what you came up with, but here's my take on it. First, I'm going to start by declaring these little pieces of logic that we wrote for consumers and producers in separate classes. So I'm just going to create a class called consumer. Let's give this an ID, because we are going to have many consumers, so we want to differentiate them in the console. So say an ID is an int, and then it will take the buffer that it's going to consume from, so mutable q of int, and this guy will extend thread. All right, and inside I'm going to override the method called run. This is from the runnable trait, and if you take a look, or if you know from the Java language, the thread class implements runnable already. So if you take a look at here, class thread implements the runnable interface, so it has the run method itself. So if you call the start method on a thread instance, it will run the run method inside either the thread object or the runnable that you pass to it. But since our consumers and producers are going to extend thread themselves, their method run says the following. So if this thread was constructed using a separate runnable run object, then that runnable's object run method is called. Otherwise, this method does nothing and returns. And subclasses of thread, which is the case for our producers and consumers, should override this method, which is what we are doing. So let's switch back to our consumer class and safely override the run method. Now, I'm going to start by copying the code from the consumer thread here, and then I'm just going to paste it inside. And I'm going to do some logic changes. Let's go create a producer class as well, because the logic changes that I want to make will be made in context. So I'm going to create a producer, again with an ID, and a buffer, which is of type mutable q. And this will extend thread as well. And I'm going to override def run with small caps. And inside I'm going to start by pasting the code from the producer. So this guy. We also have some capacity that I'm going to pass in here as a parameter. And only the producers need to be aware of this capacity. The consumers just consume until the buffer is empty, so they don't really care about the capacity, but the producers do care about the capacity because they need to block when the buffer is full. Alright, so right now nothing too special. We basically move the code to two different classes, a class consumer and a class producer. We might as well refactor our little code and just, instead of starting the threads, we could just simply create a consumer start and then create a producer then start. Alright, so right now nothing is special, but having the consumer and the producer class, we can think in perspective and imagine what would happen if we had many consumers and many producers, and that will require some changes. Now, assuming the current logic for consumer and producer, let's read this little code. So the run method from the consumer says, okay, I'm generating, having a random number generator, and I'm having a while true, which of course is the case because our producers and consumers run indefinitely. So that's not a problem. Now, in an iteration of this while true, I'm doing a synchronized code block on buffer, which says if buffer is empty, then the consumer with the ID, so I'm going to interpolate ID here, is waiting on buffer empty, and then it calls buffer.wait. Now imagine for a second the following scenario. Let's say a producer produced a value. Okay, and two consumers are waiting. So two consumers are waiting. Now, if the producer produces a value and two consumers are blocked here, and the producer calls notify, then this will notify one of the consumers. So notifies one consumer. Now, this one consumer will get out of this code and will say, okay, I have some value to DQ. I'm consuming this out. I'm going to print consumer, and I'm going to interpolate the ID here. And this will print, hey, I'm consumer number whatever, and I've consumed the only value in the buffer. And then I'm calling buffer.notify, which signals one thread. Remember, notify signals one of the waiting threads on buffer that they may continue. And this notifies on buffer. And let's say the JVM is so generous that this guy will notify the other consumer. So the other consumer says, okay, I've woken up, then there must be at least one value in the buffer, so it tries dequeuing, and this, my friends, is wrong. Oops. So I'm going to replace this if with a while, which will solve my problem. Because at this point, if I reach this point, the buffer DQ, then it must be because I am awake and the buffer is not empty. Whereas before, I would have reached this point if the buffer was not empty or I was woken up, but I now need to be both alive and the buffer be not empty. All right, so this will need to repeatedly check, okay, I've woken up. Is the buffer empty? If it is, okay, I'm putting myself to sleep again. If somebody wakes me up, I'm going to check again. Is the buffer empty? Okay, if the buffer is not empty, then I may proceed with dequeuing. All right, so at this point, there must be at least one value in the buffer because right now I've guaranteed that the buffer is not empty. So then I'll be kicking notify, which does not have the same semantics anymore. Buffer.notify will signal somebody to wake up, be it a consumer or a producer. All right. And then I'm going to put myself to sleep for whatever amount of time, say 500 milliseconds. All right. And the same piece of logic with while needs to happen for the producer as well. Because we might as well get into the opposite scenario where there is only one consumer and two producers that are operating on borderline capacity. All right. So we are going to put in a while here. and the semantics for notify here will change. This will just notify somebody to wake up if they're waiting on the buffer. All right, so now we should be good. All right, so this exercise was not really that hard to write because it's basically the same code as before with 2 semantic changes, but those are not really trivial to find. So the exercise is genuine and hard. If you did this by yourself, I really appreciate that. Now, let's go ahead and see this in practice. So let's define a quick multi-prodcons method with, let's say, end consumers, which is an int, and end producers, which is an int. So let's create a little buffer. So I'm just going to copy the buffer creation from this guy and the capacity. All right. And I'm going to create end consumers and end producers. So 1 to end consumers for each. I'm going to start a consumer. So for index I, I'm going to say new consumer with the ID I and the buffer, just start. And again, 1 to n producers for each. And for every ID I, I'm going to create a producer with ID I, buffer, and the same capacity. And then I'm going to start those. All right, so that's it. This is the whole code for multi-prodcons. Now I want to comment out the prodcons large buffer, which was our level 2 implementations, and we are at level 3, so we are becoming rock stars. So let's just go ahead and run multi-prodcons with, say, 3 producers and 3 consumers, and see what happens. So let's run, compiling, and let's see this in practice. And we have some stuff happening. All right, so I'm going to stop this. And let's analyze the output. Actually, we have a lot of producer. Let's interpolate the ID of the producer. So producer $I and producer $I as well. Or $ID. Yes. That's the ID of the producer. And let's run this again. All right. And yes, we have a lot of stuff happening. And waiting 1, 2, 3. Okay, that should be enough output for us to analyze. There's plenty of things that are happening. So as you see, producers are starting off with producing some values and the consumer consuming them immediately. But very soon, things are starting to get out of sync, and producers are producing some values and consumers are consuming some values, each whenever it gets their hands on the values inside. And we also have some situations with buffer empty, but not for too long. And we also have the situation with buffer full, with multiple producers blocking on buffer full and consumers consuming whenever they can. Then some equilibrium, and then some buffer fulls, and then some buffer fulls, and then some buffer empties. So on average, the 3 producers and 3 consumers are balanced. And now that our program runs well, we can feel free to play around with some of these values with the sleeping times and with the capacity. So I want to play with the capacity first because 3 is exactly the number of producers in our code. That is, the producers will block almost immediately once they produce 3 values. All right, so let's put some bigger number here, like 20. And if we put 20, we are going to see the situations with buffer empty and buffer full much more rarely, I think. So as you see, most of the time, the producers are producing and the consumers are consuming. So none of them are actually clashing in the sense that the buffer is empty or full, because there's plenty of space for the producers to actually insert some values and the consumer to consume some values. Notice that we might get into the situation with buffer full and also buffer empty, but that's much more rare. For most of the time, as you see, the producers and consumers are balanced. Now, I also want to play around with some sleeping time. So for example, if the producers are faster, let's say they're twice as fast. So they're waiting for 250 milliseconds. Now let's see what happens. So if I run this again, I should be getting into the buffer full scenario much quicker, even so. Notice the buffer is full so much more often now, even though there's plenty of room for the producers to produce values. And the room is filled quite quickly, and then the buffer is full and the producers start blocking. Conversely, if I modify this sleeping time again and I make the consumers faster, then this guy will block on buffer empty most of the time, because the consumers are now eager to consume values. So as you see, most of the time the consumers are blocked on buffer empty. But watch what I'm doing. If the consumers are faster and the producers are slower, but if somehow I put in 3 consumers and 6 producers, so twice as many producers as consumers, although the consumers are twice as fast, we should be getting into the similar situation of equilibrium. So let's right-click and run this and see it happening. So running again. So we have some buffer empty, but as you see now, most of the time, the producers and consumers are balanced. So on average, 6 producers operate at the same speed as 3 consumers that are twice as fast. Now, feel free to play around with these running times with the number of consumers, producers, and the capacity for the buffer, and see what interesting results you might get. Now, at this point, I'm done with producer-consumer. I think we've explored it quite a bit, and I think we have mastered by now the art of thread communications on the JVM. Let's get back to the next video where I have some small exercises for you. See you there!